Welcome, ladies and gentlemen, to problem number 6. Please look this problem over. You should have looked that over on your sheet. And we need to determine if there are any points of discontinuity of this function. Let's analyze this together. What do you see that's going on here? Do you have any ideas, any hints that you see? Look at this closely. What do you see? Ralph, George, Marilyn, Linda? Take a close look at this. What do you guys observe here? What is this telling you? Does anything stick out? Anything? Linda, Marilyn, Susan? Yes, Jack? Do you see the same thing that Jack is pointing out to us here? Yes, yes. Jack says there seems to be two values here we need to investigate. X equals 1 and X equals 2. We need to see, is the function continuous at 1 and is it continuous at 2? Alright, so let's begin to see if this thing is continuous at that. So right now, the first thing we're going to do, we're going to look at 1. We're going to evaluate the limit. Evaluate the limit in the, what I'm going to call the neighborhood. This is called a neighborhood of 1. So what I'm going to do is I'm going to come over here, use an example number line. Here is 0. Here is 1. Here is 2. So now I'm just going to draw small parentheses, and we're going to look at a neighborhood surrounding 1, meaning within this we're going to approach 1 from the left, and we're going to approach 1 from the right, within that tiny little neighborhood. That is called a neighborhood. Alright, so now we want to see what the limit is. So the limit of f of x as x approaches 1 from the left. Well, this tells us that if we have any numbers that are equal to or less than 1, we have to use that function. We have to use this expression. So now that's equal to the limit of 2x plus 3 as x approaches 1 from the left. So we're going to use x equals 1. Since that's a polynomial, we can put that in. Well, 2 times 1 is 2 plus 3 is 5. Well, so far the limit from the left is equal to 5. Okay, now let's take a look at the limit of f of x as x approaches 1 from the right. Well, now if we use this inequality, we're going to approach 1 from this side. This means we have to use this expression. So now that tells us that that's equal to the limit of 8 minus 3x as x approaches 1 from the right. And again, since this is a polynomial, I'll go ahead and substitute in that value 1. Well, 3 times 1 is 3. 8 minus 3 is 5. So far, here's what we have. We have that the limit of f of x as x approaches 1 from the left is equal to 5. And the limit of f of x as x approaches 1 from the right is also equal to 5. So now we know that at x equals 1, the limit of f of x as x approaches 1, that is equal to 5. So the limit exists at that point. So it is continuous at that value of 1. So now what we're going to do, the next thing is we're going to evaluate the limit in the neighborhood of 2. We need to look at that. We need to evaluate that point, that value, to see if the function is continuous at that. So here's what we're going to have. The next step is, again, I'll write it out, evaluate. I'm taking my time on purpose so that way you can follow along. Evaluate the limit in the neighborhood I'm calling this a neighborhood, and that's what it's referred to in other books, in the neighborhood of 2. So we're looking at points that it's really close to that. We're going to surround 2 and just give it a small area on both sides. So again, we're looking at approaching 2 from the left and approaching 2 from the right. So let's go ahead and do that. So now, the limit of f of x as x approaches 2 from the left. Okay, well, we're going to approach 2 from the left. That's in this interval here. We're approaching 2 from the left. That tells us we have to use this. So now that's equal to the limit of 8 minus 3x as x approaches 2 from the left. And that's a polynomial, so I can go ahead and take this value, substitute that into there. 3 times 2 is 6. 8 minus 6 is 2. So the limit of this is equal to 2. So that's the left-hand limit. Now let's go ahead and evaluate the right-hand limit. Right? So I'm going to take my time. So I have the limit of f of x as x approaches 2 from the right. Well, we're approaching it from the right. We're approaching it from numbers that are greater than 2. We're approaching it from this direction. So this says to use this value here. So now that expression, so now that's equal to the limit as x approaches 2 from the right. We have to use this. All those numbers that are greater than 2, we're getting closer to 2 from the right, of x plus 3. And now that's a polynomial, so I can go ahead and substitute 2 in there. 2 plus 3 is 5. We have 2 different values, don't we? Well, here's what we know. We know now that the limit of f of x as x approaches 2 from the left, well, that is not equal to the limit of f of x as x approaches 2 from the right. Therefore, the limit of f of x as x approaches 2 does not exist. It does not exist. By the definition of continuity, and I'm going to shorten this definition of continuity, f of x is not continuous at x equal 2. So there is a point of discontinuity at that value of x equals 2. So we just seen from the left and right hand limits that this function, by the definition of continuity, is discontinuous at that value. Well, now we do have enough information that we can go ahead and graph this function. So we have one value where this function is discontinuous. So what I'm going to ask you to do now, ladies and gentlemen, because as we can see also that at x equals 1, the function exists. When x is 1, that's also 5. So it exists. It meets that. Criteria number 3, the limit of the function is also equal to where it's defined. And at x equals 1, the function is 5. So at 1, this is continuous. It meets all 3 criteria of the definition of continuity. Unfortunately, for x equals 2, it does not meet all 3 criteria. The limit here does not exist in the conversation. There's nothing else to discuss. What I'm going to ask you to do now is to please pause your video, copy all of this work, and then I'm going to do the graph of this, and we're going to come back and look at that and close it out. So I'll give you a few moments to run this through so you can copy it. Then I'll ask you to pause the video, finish copying it. I'm going to erase this, do the graph, and then we'll close out. Thank you so much. Please make sure you do copy the work. Alright, at this moment, if you need to, please pause the video, copy the work. I'm going to stop it now, and I'm going to put the graph of that function on the board for us. Thank you. Ladies and gentlemen, we're back, and I have the graph here completed. So now let's take a look at this. And here is the graph. Here's the graphical information. Well, for values equal to and less than 1, at 1, it has a value of 5. So this is our point. This is our value, the value 1, 5. So this is 1, 5. And this point right here is 2, 5. And where this is an open circle, this is 2, 2. That's where the function is not defined there. It's not there because it's not equal to 2 between here. So I can't use that except it connects from here because that little circle. So here, this is the point of discontinuity where we had this jump here. So for values of x less than 1, here goes the first part of the function. And then for values of x between 1 and 2, here goes our line segment here. And then for values of x greater than or equal to 2, here goes our jump. We had this point, and it goes on this way. So that is the graph of this function. And here graphically, along with the analytical methods we just used, this highlights how this function is discontinuous at x equals 2 because the left and right hand limits are not the same. As I approach 2 from the left, the limit of that is 2. As I approach this from the right, the limit of that is 5. So those two limits do not equal, so therefore the limit at that value does not exist. Therefore this function, by the definition of continuity, is discontinuous at that value if x equals 2. Okay, if you need some moments to copy this graph, please do so. Thank you for joining me today. All of you have been an excellent class, and I'll see you in the last problem, which is problem number 7. Let me move out of your way. Again, if you have any questions about what I just did here, please make sure that you email me or call me, and I will gladly discuss any problem that I have here on my website that I'll have up here for free. If there's any questions about how we went through the analytical process, please let me know, and I will be glad to discuss this with you. Thank you so much for joining me. Please copy the problem from the board.